All right, we need to simplify this problem. So we need to simplify what's in the square root. So we still have what's out in front, which is negative 5mn cubed. And this is a square root. So we need to write what's in the square root as perfect squares. So you have to think of what's the perfect square factor of 108. So there's a couple ways to do this. You could just prime factor it. Now I know that 4 goes into it, so I'm going to divide by 4, and that gives me, let's see, 27. And I chose 4 because that's a perfect square. And I think, is there a perfect square that goes into 27? It's 9 times 3. So somebody else might have realized it was just 36 times 3. 36 is a perfect square, but I did it this way. So I'm now going to write that as 36 times 3. You could also write it completely prime factored, or as 4 times 9 times 3. So I'm going to write 108 is 36 times 3, because there's a perfect square. And m to the 16th, when you have an even exponent, that's already a perfect square. But for n cubed, 13 is odd, so I want to write this with an even exponent, so n squared times n. And now we could take out the perfect squares. So 36, that's a perfect square. A 6 will come out. For m to the 16th, it's half the exponent. M to the 8th will come out. And n to the 12th, n to the 6th will come out. So everything I'm writing up here gets multiplied by this negative 5mn cubed. So let's do that. We have negative 5 times the 6 will give you negative 30. I have m times a m to the 8th. Remember, that's a m to the 1st, even if you don't see it. So that's going to give me an m to the 9th. We have n cubed times n to the 6th. So if I add those exponents, I get n to the 9th as well. Same exponent, just happened to turn out that way. And I still have a 3 and an n underneath the square root. So that is the simplified answer.